We want to find an equation of a polynomial function with real coefficients having zeros 2 with multiplicity 2 and negative 1 minus 2i. So there are a couple things we need to be aware of here. First, if the 0 of 2 has a multiplicity of 2, that means it's a double zero. So if we were going to list the zeros, we could list 2 twice. Next we have the complex 0 of negative 1 minus 2i, but complex zeros come in conjugate pairs, so if negative 1 minus 2i is a 0, then so is negative 1 plus 2i. So we actually have 4 zeros, and knowing the zeros of a polynomial function gives us information about the factors of the polynomial. The polynomial function must contain factors in the form of x minus the given zeros. So if 2 is a double zero, we must have two factors of x minus positive 2. And if negative 1 minus 2i is a 0, we must have a factor of x minus negative 1 minus 2i. And if negative 1 plus 2i is a 0, we must have a factor of x minus negative 1 plus 2i. Now we could also put a constant here, but since we don't have any fractions in our binomial factors, we won't include one. Now we need to find this product, but before we do this, to multiply these last two binomials, it'll be easier to keep track of the signs if we eliminate the parentheses inside our factors. To do this, we can think of distributing a negative sign, or a negative 1 here, as well as here. So we have f of x equals, we still have two factors of x minus 2. And now here we're going to have x, we distribute the negative 1, we're going to have a positive 1 plus 2i, or plus 1 plus 2i. And then here, when distributing a negative 1, we're going to have plus 1 minus 2i. So x plus 1 minus 2i. Now we need to multiply all this out. To do this, we're going to multiply 2 at a time. We'll start by multiplying these two factors. Then we're going to multiply these two factors. And then we'll find the product of these two products. So we'll have f of x equals, here we have four products, x times x, that's x squared. X times negative 2 is negative 2x. Then we have negative 2 times x, that's another negative 2x, so we have minus 4x. Negative 2 times negative 2 is positive 4, so plus 4. Now here we have 3 terms, and here we have 3 terms, so we'll have 9 products of x times x, that's x squared, x times 1, that's plus x, x times negative 2i, that's minus 2xi. Then we'll distribute the 1, so 1 times x is x, plus x. 1 times 1 is plus 1. 1 times negative 2i, minus 2i. Now we're going to multiply by the 2i. 2i times x, plus 2xi. 2i times 1, plus 2i. And 2i times negative 2i, that's minus 4i squared. Remember, I squared is equal to negative 1. So now we need to simplify this, replace I squared with negative 1, and combine like terms. Here we have minus 2xi plus 2xi. That simplifies to 0. And here we have minus 2i plus 2i. That simplifies to 0 as well. So now we have f of x is equal to x squared minus 4x plus 4 times the quantity x squared. We have plus x, that's plus 2x. And then we have 1 minus 4i squared, but I squared is equal to negative 1. So negative 4 times negative 1 becomes plus 4. 1 plus 4 is equal to 5, so we have plus 5. Now we're going to multiply these two trinomials together to find our polynomial function. And again, we have 3 terms here, 3 terms here, so we'll have 9 products. So we'll start by distributing the x squared here into the second trinomial. X squared times x squared, x to the 4th. X squared times 2x plus 2x cubed. And x squared times 5 plus 5x squared. Now we'll distribute the negative 4 into the second trinomial. So negative 4x times x squared is minus 4x cubed. I'm going to go ahead and write this under the x cubed term. This will make combining like terms much easier. Negative 4x times positive 2x, that's minus 8x squared, which I'll put under the x squared term. Then we have negative 4x times 5, that's minus 20x. And now we'll distribute the 4 into the second trinomial. 4 times x squared, that's plus 4x squared. Again, I'll put this under the x squared terms. 4 times 2x, that's plus 8x. Put this under the x term. And then we have 4 times 5, that's plus 20. And now that we have this lined up vertically, we can easily combine the like terms to find our polynomial function. So we have x to the fourth, 2x cubed minus 4x cubed, that's minus 2x cubed, 5x squared minus 8x squared, that's negative 3x squared, plus 4x squared, that's plus 1x squared, or plus x squared. Negative 20x plus 8x is minus 12x. And we have our constant of plus 20. This is an equation of a polynomial function of degree 4 that would have the given zeros. We can verify some of this graphically. If we graph this function, because we have a double zero at 2, or a 0 of 2 with multiplicity 2, the graph should touch the x-axis at positive 2, not cross through it. So if we graph this function, the graph would look like this. Again, notice how it does have an x-intercept of positive 2, where it touches the x-axis, but doesn't cross it, because the 0 has multiplicity 2. And because the other two zeros are complex zeros, graphically, they do not produce x-intercepts. Okay, I hope you found this helpful.